The binomial theorem of the zeta function is established in all positive and negative domain, and can be inversed by the functional equation of analytic continuation. The binomial theorem of the zeta function for negative integers requires a correction term due to the pole of s equals 1, and the binomial theorem of the zeta function for natural numbers is not established because the gamma function of the binomial coefficient for a negative integer becomes infinity. However, it is also established for real numbers and complex exponents, excluding integers, and since the zeta function and the odd zeta function and the subordinate zeta function can be obtained from each other, the gamma function relation of the zeta function can be derived from the binomial theorem of the zeta function. And the inversion of the gamma function relation of zeta function by the functional equation is the same as the inversion of the binomial theorem of zeta function. The subordinate zeta functions 3, 1 and 3, 2 can be obtained by the binomial theorem of the sum and alternating sum, and the subordinate zeta function m, n of s is equal to n to the minus s power plus m zeta plus n to the minus s power. Therefore, 2 to the minus s power is added to the sum of the subordinate zeta functions 3, 2. The binomial theorem of the odd zeta function and the subordinate zeta function has significantly less error. Even if the subordinate zeta functions are calculated with the zeta function up to 170 terms, the binomial theorem of the sum and alternating sum is almost identical, and it also shows an error of more than 10 decimal places with the red zeta function by the mathematical function. If it is calculated up to 1,000 terms of zeta function with Wolfram alpha, it matches more than 64 decimal places. Blue and green are the sums of the two subordinate zeta functions 3, 1 and 3, 2, so they are identical to the zeta function of 1 minus 3 to the minus s power. Also, brown and purple are the differences of the two subordinate zeta functions 3, 1 and 3, 2, so they are the same as the L function of mod 3. The L function of mod 3 at s equals 1 is pi over 3, the square root of 3, and the L functions of brown and purple also approach 0.6045997. GeoGebra shows the binomial theorem of the zeta function up to s equals 1.62, but in reality, it holds in all regions and shows the relation between the zeta and eta functions.